Hi there guys, and we're going to have a quick look at some more harder differentiation questions. I've called this part 2, and you can see straight away that they're a little bit more complicated. Okay, so this first one, really common that we give you things like this. So it's not in its normal form, it's in a factorized form. Now, is this in the form of ax to the n? No. So that's what we've got to do, we've got to expand it. So you should be pretty good at expanding by this stage you learn calculus, but I'm going to do it nice and slow. So 2x times x, well that's 2x squared. 1 lot of 2x, that's 2x. And we've got 5x there, so that's a total of 7x's. And 5 times 1, well that is 5. So this is a method we call FOIL, you know, the first terms, the outer term, the inner terms, and the last term. So FOIL's, yeah, it's called an acronym, isn't it? Acronym of those. Okay, so everything's in index form, and now we can differentiate. So people panic when it's given to this form. Just expand it. It's the only thing you can do in this situation, and then go. So it's going to be 4x, reduce the power by 1, so it's just x, times by the 1, so 7 times 1 is 7, and that's it. So this is our gradient function, this is our derivative. Okay, these are particularly hard. Now, what's happening here is they have a shared denominator. Now, I'm going to quickly do a really simple sum for you here. So let's do this. 5/7 plus 1/7. Everyone knows that it's, hopefully everyone knows, it's 6/7. Now, what's happened here, if we want to go backwards, as you can see, we've split this one term into two terms. As long as the denominators were the same, it allowed us to combine these tops. So we're going to do that. So instead of having one common denominator, we're going to rewrite it so that same denominator is under both terms. So we have x cubed over x squared minus 3x over x squared. Okay, so it's in your interest now to try and cancel down. So I will just show you an example of what I mean here. So this first term, this one here, that's x times x being divided by, I'm really sorry for my horrendous fraction lines, divided by x times x. So x divided by an x, how many x's are there in x? 1. And again, I can cancel out there. So I'm left with 1 times 1 times x, which is just x divided by 1, which is just an x. So this is y, this is y. Now, same thing here, so it's an x divided by an x. So now I'm going to end up with this. So I'm just going to rewrite that so it looks a bit tidier. Okay, now this is an index form, so I can't differentiate it. I'm just going to delete this bit down here. So I've got to do my rewrite. That term's fine. This term is x to the minus 1. Now I can differentiate. There's quite a few steps, but you'll get the hang of it. So it's going to be 1 plus 3x to the minus 2, and then my final rewrite to put it back. So remember, 3 on top, the power on the bottom, but now it's positive. Okay, same thing here. So split them up. Oh, pause the video, have a go if you're confident, but if not, just pause each stage if you need to. Just make sure you're watching the videos correctly. You should never really watch a video without using the pause button, without being interactive. Okay, so rewrite using this knowledge. Now look to cancel, so x divided by, this is, remember, x times x, so let's get rid of that 2. And here we've got x times x times x divided by x times an x, so those 2 are going to go. That leaves us just 1 at the top here. I'm going to rewrite it. I like to rewrite it because it gets a little bit messy. Okay, this is a situation we haven't seen yet, which is great. Okay, so y, y, and a y. This isn't in index form. This form ax to the n, so we have to rewrite it. Now, what this is I could write it like this. In fact, I need to just make that a bit further over. So this is the same as this. Okay, so to get 2 over 7x, this would give me 2 over 7x. So if you think about that as x to the minus 1, we've actually got 2/7 of x to the minus 1. Now I could combine these two as a numerator if I wanted to, so 2x to the minus 1 over 7. I just prefer to do it like this. And this one's actually fine. This is in index form. I can rewrite it like that if that helps. Okay, so time to differentiate, and we'll probably have to do a rewrite at the end. So what's minus 1 times 2? And the reason I said times 2, because when we times fractions, we're only times in the tops and the bottoms. Because this whole number is, because this power is a whole number, for example, like that, I would only be timesing the 2 by the 3 because of this reason. So we're going to have minus 2/7 of x, and that's going to be to the minus 2. And we're going to be left with minus 5 over 7. I'm sure you're pretty good at this if you're at this stage. Okay, so we have to do a rewrite. So we're going to have minus 2. What I'm going to do is just put it there. Now please remember, it's the same as this. So you can see minus 2 times 1, but that's your minus 2, and 7 times x squared is going down there. So it can get a bit trickier when you've got a fraction as a coefficient, but it's exactly the same. Minus 5/7. Okay, and it's absolutely fine to leave it like that.